Ready?
Mm-hmm.
Okay, go. I am doing a presentation on wind energy for residential use. My name is Kristen Johansson, and I'm a senior engineering technology student. We're going to talk about some of the benefits about wind energy in the home. First, what is wind? Wind is caused by many different variables going on with the Earth's rotation, the different vegetation at different elevations, the tides with the ocean, and then, of course, the sun. One way to collect all this wind to generate power is with a wind turbine. So the wind powers the turbine to spin, catching the wind on the blades, and basically when it spins, it's gonna convert the wind into electricity. And it's gonna spin the blades, which turn a rotor, and the rotor turns the drive shaft, which powers an electric generator in the back of the turbine. And then it gets moved out to transmission lines, and so on and so on. Placing a turbine is very specific. You can only place so many in one area. You have to have more than an acre. For major wind farms, there's a specific design you have to follow. They have to be so far apart, so far spread apart. Normally they're in just a normal line fashion, but they are the diameter of the blade at rotation and a half apart from each other. Okay. Also, the placement depends on the wind speed, the air density, and the swept area that the blades reach. So a smaller diameter of the blades will not catch as much as a larger diameter. I think that's the next slide. So first you want to calculate the wind power for that area. This is calculated for a specific instant, so it's not going to be the wind power 10 minutes from now. With this calculation, you can actually calculate the capacity factor, which is the main point of a wind turbine. Is the higher the capacity factor, the more efficient the turbine is. So first you would calculate the wind power, which is power equals 1/2 air density times the area swept times the volume cubed. Right?
Uh-huh.
No, the volume, the wind speed cubed, my bad. So the greater the wind speed, the more you can capture. And the capacity factor, I think that's it, is the average power over the rated power. So your average power for a month, for a year, however you want to do it, divided by what it's rated at. Your turbine is rated at. And this is also dependent on a specific time period. Sometimes they're going to be greater than others. Some years, some months are going to be very different than another. So another thing going into, now we're going to start talking about the residential area and where you would want to actually, if you wanted to build a turbine, where would you put it, how would you go about it. This is the Texas Annual Average Wind Speed Map at 30 meters, which is typically the height you would have a residential small scale turbine. Obviously you could see the Panhandle region is the best. You would not want one in East Texas or anywhere where there is green. You're not going to have a good average wind speed of 4 meters per second on a daily occurrence. It's not worth the investment. And also another factor that goes into it, if you're not picking a specific turbine with a specific manufacturer, if you have to service your turbine the first year after they install it, it's not even worth getting, because those maintenance fees and service fees are really expensive because it's a specified field. Another good use, if you want to do a residential wind turbine, maybe you don't want it to power electricity because it's not efficient for you, but you're in an area where the water table is pretty close. You can do a typical windmill to pump water. These areas have medium to high winds, and the water is only 30 feet to 220 feet deep. So around here, it's not as efficient as it once was, considering the Ogallala is being depleted. But areas where you can, more up Nebraska area where the Ogallala is very close and it's recharged all the time, that would be a good place for it. The source I use to get some of this information that I'm about to talk about is the Wind Powering America, and also the famous Wind Energy and Renewable Energy and the Environment by the famous Vaughan Nelson. So to have your own residential wind turbine, you have to meet all state laws, local law regulations. So you might not be able to have one in a good area just because of state laws, but you have to have a minimum of 1 acre. You have to have an average speed of 4 meters per second to be able, your rated speed is 4 meters per second if you're able to start a small wind project. You have to check your zoning code, so that's also checking with the local government to make sure it is allowed. And then you have to check for the production of electricity. If your utility will also hook up to it. If not, if you're going to just be running it by yourself, or you can get state incentives for it. A good way to know if you should do it is if your electric bill is $150 or more every month, then it's probably a good idea if you meet all the requirements. Some of the small wind turbines range from 20 watts to 100 kilowatts. The smaller wattage from about 20 to 500 watts are just used to charge batteries on like an ATV for a sailboat was one of the examples. So you can do a smaller one, but it's really not worth it. The 1 kilowatt to 10 kilowatt are used for pumping water, so that's good to know if you want to just have a windmill for water use. A good thing about the windmills for pumping water is they don't have to be directly above the well. You can have a mechanical electric system that a cable is connected from the pump to the windmill wherever that placement may be. So that's always good, but when a normal wind turbine generating electricity, you have to be in the specific spot. A normal residential small turbine is 400 watts to 100 kilowatts. The saying goes, energy efficiency is usually less expensive than energy production. So if you can go about not getting a wind turbine and start sealing up your windows, your doors, your foundation, doing other measures, you want to do that before you even go about trying to put a turbine on your property. A 1.5 kilowatt turbine will meet your home needs if you're requiring 300 kilowatt hours per month in a location with the average wind speed of 6.26 meters per second. So that's not a lot of areas. So when you're considering doing a residential turbine, it's really not too practical for you unless you're out in the middle of nowhere with those high wind speeds. Like here in Amarillo, for all the wind turbine farms that are around us, the wind can get really high speeds. And so on the wind turbine, they actually have a governing device so that they are not going to spin out of control and they will not overproduce electricity, or not even, they would just really stop working. So also they have those on the small wind scales because some of those smaller diameters are going to spin a lot faster in really, really high winds, but they have a governing device on them so they don't exceed the out of control limits. The small wind energy systems have an average cost of $6,900 per kilowatt installed. So you really got to be financially stable to be able to go about this also. A lot of times you can price out these small turbines between different manufacturers. The Small Wind Certification Council will also help with this information, so you don't have to go out about it alone. You can talk to other people and see what they have done. There's also a list for small turbines that are certified for incentive funding. So you can get money for overproducing. You could be hooked up to the utility grid, which is called net metering. And if you're making more than what you need, you can sell it to the electric company. And if you can't do that, they will meter what you are making. And if you overproduce at a time and you're not making enough at one time, they will roll it over on your bill. So you're still making all your electricity and not having to pay for the utility grid electricity. And the good thing about this long-term investment, if you do go about buying a small wind turbine, is that it should last 20 or more years. So this is a long-term risk investment, high risk, definitely, because you don't know the wind speed's going to be 2 years from now on this date. So, but they do last a really long time as long as you're up to date on regular maintenance, which is a specific fee. The only way to go completely off grid with your small wind turbine is if you can't be connected to a grid, or it will cost you more than $15,000 to hook you up to a grid, which that is an outrageous amount of money just to put some lines in and hook you up to some electricity. So there's other ways to go about going completely green. Is you can also do solar energy with some PV cells. You can also, you have to find a way to heat your water. There's many different other things you can do to go green without having to go all into just wind energy. And I think that's it.